Welcome to this explainer. Today we're actually going to pop the hood and look at the hidden engine of the modern world, data architecture. We're going to trace exactly how the systems powering our digital lives evolved from rigid digital filing cabinets into the incredibly powerful predictive platforms that we rely on today. So let's just jump right in with the million-dollar question, right? How on earth do modern companies analyze billions of data points in milliseconds without completely crashing their servers? It's a massive, mind-boggling challenge that engineers have been tackling for decades. To figure that out, here's our roadmap for today. We're going to cover the traditional database era, the rise of data warehouses, the Hadoop revolution, the data movement bottleneck, and finally, bringing algorithms to data. It's literally a journey of continuous innovation. We'll see how engineers solved absolutely critical scaling bottlenecks era by era, from the foundational systems of the 1980s all the way through to the advanced analytics of the 2010s. All right, part one, the traditional database era. Back in the day, these structured relational databases were essentially digital filing cabinets. They were perfect for daily tasks. They use SQL to organize data neatly into rigid rows and columns. And they're fantastic at simple stuff, like inserting a new customer or, updating an address. But the moment a business tried to run massive, complex analytics across millions of records, the system just completely choked. It turned into a tangled, overworked mess. So to fix that, we enter part two, the rise of data warehouses. The big aha moment here was to extract, transform, and load the data from those everyday systems into one massive central warehouse. Because think about it, if you run heavy analytics on live operational systems, you literally risk crashing day-to-day business operations. So instead, the data gets safely moved into a dedicated environment built specifically for complex querying and business intelligence. And this is where OLAP, or online analytical processing, completely changed the game. Think of OLAP as pre-programmed data cubes. They basically lock in specific dimensions ahead of time, say viewing sales by region and then by quarter. By pre-calculating this stuff, you can generate massive, multidimensional reports at lightning speed without ever touching the live systems. But then, the internet exploded, which brings us to part three, the Hadoop revolution. With the rise of social media and web data, we suddenly had to address the elephant in the room, literally, Apache Hadoop. This open-source framework was built to store and process staggering amounts of unstructured data. We're talking petabytes here. And it did it far cheaper than the old method of just buying a bigger, more expensive centralized server. How does it handle all that volume? Well, Hadoop uses MapReduce, which is this brilliant divide and conquer strategy. Step one, you split the massive data set into much smaller, manageable chunks. Step two, you apply the query in parallel across a whole network of distinct server nodes. And finally, step three, you combine all those individual results back together to get your answer. So what you end up with is this incredibly powerful hybrid environment. You've got Hadoop sitting right alongside your traditional data warehouses. This lets companies process wild, unstructured data, like social media feeds or electronic sensors, while still keeping their highly structured business data locked down neatly in the warehouse. The whole shebang just gives data scientists a complete, powerful toolset. But of course, a new problem popped up. Part 4, the data movement bottleneck. Here's the issue. Moving petabytes of data over to a separate analytical server is literally like trying to move a mountain to a tiny processing factory. The absolute absurdity of exporting massive volumes of data out of the warehouse just to run a machine learning algorithm became the industry's biggest, slowest bottleneck. It takes too much time, costs way too much money, and honestly introduces a huge risk of errors. So, how do we fix it? Part 5, bringing algorithms to the air. Actually, the fix was pretty genius. Instead of moving the mountain to the factory, we just built the factory directly on the mountain. We flipped from the old way, exporting all that data out to an algorithm, to the new way, running machine learning algorithms directly inside the database itself. By embedding those algorithms right inside the database, we completely eliminate that slow, error-prone data extraction and loading loop. The analytics engine now lives exactly where the data lives. It's a massive paradigm shift. And the performance gains here are just staggering. First off, you get zero data movement, which means extraction delays are completely gone. Second,
Blazing speed. We're talking up to 100 times faster than traditional export methods. Third, infinite scalability, because it taps right into the database's built-in parallel processing power. And honestly, best of all, data scientists can deploy these models using a unified, standard language they already know, SQL.
And this isn't just some theoretical whiteboard concept. It is actively powering split-second analysis in massive commercial applications right now. Take Wargaming, the creators of the hit game World of Tanks. They use in-database machine learning to predict and manage interactions with over 120 million customers in near real time. That kind of instantaneous analysis, it's literally only possible when your algorithm sits right inside your dataset.
It's pretty mind-blowing when you think about it. We've gone from the basic rows and columns of the 1980s to this. So I want to leave you with a provocative thought to chew on. As data continues to grow infinitely, will the databases of tomorrow just become completely self-learning systems? Thanks for joining me for this explainer. Keep questioning, keep analyzing, and I'll see you next time.